not trivial. Consider the following. Notice, these are mechanical toys. Here is a little propeller, and it has three blades, and they are pitched in a very certain way. Now I have wound up, oh, that one is wound. Let me take, there. Oh. What am I doing? Well, there's a little trouble with that spring. I have stored some twist energy in a spring. When I release it, it will unwind, and that propeller is going to go up. Why? The blade is pitched. So as the whole wheel turns, the blade grabs some air, as we would say, and pushes the air down, and that's why it goes up. So a bird can fly only because he pushes the air down and he goes up. Conservation of momentum, we call it. Watch it. There it is. And of course, there I have a spinning top, which I could talk about for an hour. Let me do another one. Oh, watch it now. Watch it. Oh, way up, and there it comes. And we have a spinning top on the floor, which perhaps can be caught by the camera, and that's so. Very good, men. Okay, mechanical toys. Another one. Here is a wonderful one. I don't like to play much with weapons of war, so you have once detected my philosophy, but this is rather harmless. Here is a hollow chamber in the shape of a gun. The chamber is, as one would say now, empty. Oh, no. It's filled with air. And here is a ping pong ball. And I put the ball in there. And now I squeeze suddenly on here, and the ball emerges. Indeed, I have made a very profound experiment out of this. If I shoot this ball at some angle with the horizontal, and then at another angle with the horizontal, and then at another angle with the horizontal, I find very nearly the following, and this is quite amazing. If one shot a projectile like that and it took this flight, the question is, when would you expect maximum range? Well, theoretically, maximum range is at 45 degrees. And so we can show that with this toy. Now, there is another interesting problem. Galileo showed that if there is a target intermediate in here somewhere, that target can be hit by this weapon by two routes. One that goes like this, and one that goes like this. And they have very interesting properties. This smaller one is as much smaller than 45 degrees as this one is bigger than 45, which is a very exciting thing. And Galileo did this in the 16th century. So you see, people, that playing with a toy, this may be for child's play, but the physics ceases to be child's play. It can be very substantial business. Let me show you another one. Here I have my monocyclist. Mono, one, cycle, wheel. Monocyclist. Here I have a string, one end of which is fixed to a support there. Now you know that if I put this monocyclist on this string, the center of gravity of the cyclist is far above the point of support, whereupon, as we say, the system is unstable. Unstable. Very certainly will tip. I wish to do two things. I want to make him more stable. How can I do that? I can do that as follows. I can load his arms with a stick and a heavy weight. Here's the weight, a lead weight. Put such in each arm. Notice I'm getting a little entangled here. Put one in each arm. I'll go get my string again. And now let me discuss the physics briefly. Mark you, people, I am giving only the most superficial inquiry into the matter. Each one of these toys could have 100 pages of mathematical physics written on it. So I am disposing of it quite in a trivial way. What have I done? I have lowered his center of gravity below the point of support, and I have also increased what we call his moment of inertia. I have made his mass far out from his central axis, and now we hope he can ride with absolute immunity. Watch him. There he goes, and there he comes back, and there he goes, and there he comes back. And the faster he goes, the more stable, which is because the wheel has a certain gyroscopic property, which I have no time to engage in here. So the monocyclist lowered the center of gravity below the point of support and increased the moment of inertia. Let me say a word more about that. Supposing I'm an ice skater, skating, and I stop with one leg up and both arms out, and I spin at a certain speed, pirouetting. My mass is far distributed from my axis of rotation. Now I drop my arms. My moment of inertia becomes less, and my angular velocity very much more. Or, consider finally another. Here is a little dog with a flexible neck, and I push his nose down into some stickum stuff. I push his nose down. Watch now. Watch. Watch it. Watch him. Come on, come on, come on. Oh, come on, you rascal. He stuck him too much. Oh, well, notice, what I wanted to show you is that he rotates about his center of gravity and would land on his feet. And thus I have explored in a trivial way the wonderful adventures in the physics of toys. And I thank you for watching.